Okay, today we're going to be doing 8.4. We're going to be solving logarithmic and exponential equations. These were just some of the basics that we had learned about the logs sitting in 8.1 through 8.3. We're going to use some of those principles to help us solve the equations. We're going to apply a lot of algebraic principles to these. They should be fairly easy. Okay, I want to get up to this x. I need to solve for x. It's in the exponent, and I need to get it down. What I'm going to do is just have everything take log base 4 on both sides. Actually, let me do it this way. It might look a little bit better so you can see it. Log base 4 to 4x, log base 4, 10. And the reason I want to pick log base 4 is because the base of the log equals the base of the power. They'll cancel each other out. I'll be left with x. This part here, we can put in a calculator just as you are. If you don't have a calculator that will let you put in a base other than 10, you can use your change of base formula over log base 4, and you get x to be about 1.66. Alright, so looking at b here, again I want to kind of isolate the x. I'm going to take that 27 over to the other side. Looking here again, I need to get up into this exponent here, so I'm going to take log. Again, I'm going to use base 4 to match that base. Equals log base 4 of 27. These guys will cancel here, leaving us with 2x minus 1. This part here, I'm using a calculator to get this number. I'm getting about 2.388. And then it's just solving an algebraic equation. Add the 1 over. And finally, divide by 2. And this turned out to be about 1.69. Alright, so let's take a look at C. Here. I noticed here that we have exponents on both sides of the equation. And again, we could do anything we want to these equations, so long as what we do to one side we do to the other. Since we have different bases, I'm just going to take natural log of both sides. You could choose to do log base 10. For me, it's just easier to write ln than it is log. So first thing I'm going to do is take the natural log of both sides. Alright, and when we were expanding our logarithms with the exponents, we were able to move them to the front of the log. So I'm going to do that now. Natural log, I think I forgot to, 3. That's right, the 3 there. Okay. I'm literally going to distribute this natural log here and here inside to the parentheses on both spots. So now we're going to have natural log x times natural log 4 plus natural log 4 is equal to 2x natural log 3 minus natural log 3. And just like in any algebraic equation, these are just numbers here and here. We're going to get the numbers on one side and x's on the other. Alright, so bring in the 2x to the left, and we're also going to bring that natural log 4 over to the right. At this point, just like in an algebra problem, I want to isolate these two x's. They're common to both terms, so we're going to factor them out. And at that point, I'm running into the problem over here. Again, this is just a numeric value, so we're going to divide everything through by natural log 4 to natural log 3. That will cancel that out. You put this guy into the calculator, and you should get x to be about 3.06. Please practice with the calculator here. You want to make sure you're inputting correctly. If you're having calculator issues, remember to ask your teacher. Okay, let's make that go away so we can just concentrate on D here. The first thing I'm going to do is just do a little cross multiplying here. So I'm going to have e to the x. At the same time, this negative here means that e to the x is in the wrong part of the fraction. It really belongs in the denominator. I'm going to put it there. Is equal to 2. I don't like to solve any equations that deal with fractions, so I'm going to multiply everything through by e to the x to cancel that out. What I get here is e to the x squared, because we're multiplying to itself. Here, these two here and here will cancel, leaving us with plus 1 is equal to 2 e to the x. This is starting to look like a quadratic, so I'm going to scoot everything over to the left side. That's going to equal 0. This guy is factorable, and he's going to factor into e to the x minus 1, e to the x minus 1 equals 0. It's really e to the x minus 1 squared equals 0. So we find that e to the x is equal to 1. Take the natural log on both sides to cancel out, and we find that x is equal to 0. Alright, so let's take a look at E. E is going to work a lot like problem B did. First thing we're going to do is take that 16 over to the other side. This one's actually slightly easier than B. So I'm looking at 16. I know 16 is 4 squared. So I'm going to change this guy here to 4 squared. And the reason I want to do that is because now the bases are the same. And if the bases are the same, we can just set the exponents equal to each other. So then I get 2x is equal to 3, and x is equal to 3/2. So that one was pretty easy to solve. Here I'm going to put the 7 to the 4x over on the other side. Just like in the problem up above, problem C, I'm going to take the natural log of both sides. And again, when we're expanding, we can take those exponents and move them up front. On the left side here, I'm going to distribute, so we're going to get 3x natural log 5 minus natural log 5 is equal to 4x natural log 7. I want to gather the x's on one side and the numbers on the other, so I'm going to wind up with 3x natural log 5 minus 4x natural log 7 is equal to natural log 5. Again, we share an x in both terms, factoring that out. Natural log 7 is equal to natural log 5. Divide everything through by 3 natural log 5 minus 4 natural log 7. And again, it's just calculator work at this point. You should be getting x to be negative 0.54. Okay, so those were our equations with exponents. Turn your papers over. We're going to be dealing with the equations with the logarithms. So the first thing I notice here is each of these logs are base 4. So I'm going to turn all these into exponents, and I'm going to use a base 4 in my power. So 4 log base 4, 8 is equal to, I'm also going to bring this 2 over here, 4 log base 4 x squared. And the reason I did that is because the base of the power equals the base of the log. So we're looking at the same here. So we're going to wind up with 8 is equal to x squared. I got x is equal to 2 root 2. I'm okay with the decimal answer. I just didn't do it that way, and I'm not sure what it is. I don't have a calculator with me right now. So I'm looking at this one here. The first thing I think I'm going to do is, we could do a couple of things here. Well, let's take this 2 over to the front. So we have 2 natural log x plus 1 is equal to 2. I could divide everything through by 2. Now I just have natural log x plus 1 is equal to 1. Let's put them again up into exponents. I'm going to use base e, because remember natural log is really base e, leaving us with x plus 1 is equal to about 2.718, and that's what is e's equivalent. subtract the 1 over, we get x is equal to 1.718. Alright, so let's take a look at D. In order to solve these logarithmic equations, you do need to condense them down first. So I do want to combine these guys up. So I'm going to have, now remember the plus means we're going to have a multiplication. So this is going to be the log of x plus 1 times x minus 2 is equal to 1. Since I don't see a base, I know it is base 10. I'm going to move both of these logs up into exponents. So I'm going to have a power of 10 here. These guys will cancel out. I'm going to multiply through at the same time. So you're going to get x squared minus x minus 2 is equal to 10. Subtract the 10 over. This is factorable. So we get x and 4 and 3 minus and plus. So I find x equals 4. X is also equal to negative 3. This is extraneous here because we cannot take the natural log of a negative number. Remembering the graph, we had the asymptote sitting on the y-axis. Okay, so this problem's a little bit long. It's probably the hardest one. It's not too bad, though, on our notes here. First things first, I noticed that I have different bases here. So the first thing I'm going to do is use the change of base formula on this piece, and I'm purposely going to choose log base 2. So I'm not doing anything to this term here. I'm just going to bring it down. So using our change of base is going to be log base 2 of x over log base 2 of 4. And again, I'm choosing base 2, so all my bases here match up. Now 4 is really 2 squared. Rewriting all that. So I have log base 2 of 2 squared. There's a lot of 2's here. Now this base of the log equals the base of the power, so that's going to cancel out. I still haven't done anything with this first term yet. So now I got minus log base 2x all over 2. And all of these have been equal to 1. Alright, now again, I don't like to do anything with fractions. I'm going to multiply everything through by 2. So now I have 2 log base 2 x plus 1 minus log base 2x is equal to 2. I'm going to condense now. So this guy's going to come up here, and this minus here is showing a division. So we're going to have log base 2 of x plus 1 squared over x is equal to 2. So now I want to get rid of this log. I'm going to move everything up to an exponent. I'm going to have a power here with base 2. And again, the reason I'm picking 2 is so that these guys cancel out. So now I've got x plus 1 squared over x is equal to 4. Now we're just solving the equation. So expanding this here, you get x squared plus 2x plus 1 is equal to 4x. It's a quadratic, setting everything equal to 0. This factors into x minus 1. X minus 1 equals 0. And after all that solving, we find x to be 1. Alright guys, we've got 2 more to go, and then we're done with our notes for today. So again, if you have a logarithm here, it must be condensed first. The plus sign here is showing a multiplication. So this is going to be log x plus 4, x plus 1 is equal to 1. I need to get rid of that log. It is base 10. When you don't see it, it is base 10, so we're going to put it down to a power of 10 here. That's going to give us, let's see here, x squared plus 5x plus 4 is equal to 10. Subtracting the 10 over, we have a quadratic. And then this is going to be factorable. We have x and 6 and 1, plus and minus. So x equals negative 6, x equals 1. Again, this is extraneous. We cannot take the log of a negative number. Combining this guy up here, again that plus is indicating multiplication. So we have log base 3 is see, a 5x minus 12 times x is equal to 2. I need to get rid of this log. I see it's base 3, so we're going to have everything in base 3. So I wind up, I'm going to multiply out here too. 5x squared minus 12x is equal to 9. Quadratic, put everything on the left side, set equal to 0. Oops, 0 there, sorry about that. 5x and x, and this wound up being 3 and 3 plus and minus. So here we get x is equal to negative 3 over 5. X is equal to 3, and again we have an extraneous solution here. That concludes our notes for today. Our next set in 8.5 will be more application based. I will see you next time.